Hey guys, welcome back to AlgoYogi. We are doing trees problems right now, and our next problem in the list is smallest string starting from leaf. So let's go to the problem on LeetCode. So you are given the root of a binary tree where each node has a value in range 0 to 25, and that represent basically smaller case alphabets. Now we need to return the smallest string lexicographically, which is basically the order in which the values occur. So A will be smaller than B, will be smaller than C. So in that way, lexicographically, smaller value would be A, then B, then C. So just like here, they have shown us the example. AB is lexicographically smaller than ABA, since now B is being appended to the same prefix, so that makes perfect sense. Now let's try to understand how we're going to solve this problem. So let me tell you that just a normal string comparison in Python would give you like a smaller string or bigger string. If you're comparing just two string together, it will compare them lexicographically, so we wouldn't have to worry about that. It's just we need to find the paths, all the paths, and compare them and return the minimum path, basically just comparing these two different strings that we're going to combine from leaf to root. So just like in the first example, you see this is one path, and this will give us this string DBA. Another path would be this, and that would give us the string EBA. And we have two more paths, and these are them. This would give us DCA, and our last path is this, which gives us a string. I think you guys can see. So this gives us ECA. And remember, we are basically combining this string from leaf node to the root node. So in case you were wondering why it's not AB, ABD, and why it is DBA. So the answer here would be DBA, and the reason is that basically D occurs before E, and comparing these two, we're going to compare the second index, and we know B occurs before C. That's why this is the answer. Rest, this is same as, and even this wouldn't matter because we have a bigger string at the same index. So wherever we have like a bigger string, that means that is not what we're going to return. We're going to return the smaller one. So it's simple DFS algorithm, which will take big of n time, and only thing is we have to keep track of the string that we are formatting, so we can call it current value. And as we are traversing our tree, then we can keep updating that value. So when we are starting at let me just erase this and show you guys. So if we are starting at A, then my current value would be A. Then I start exploring the left side, which is B. Then my current value become BA. Over here it will become DBA, and that's where I will know that this is the leaf node, checking it doesn't have any left and right children. Then that's where I will basically return this string. But returning this string means that later I have to compare it with whatever is coming from the right side. It could be none. If it is none or nothing, then I will return back this value. However, current value will keep getting updated, and here it will become DBA. So BA comes from here. So I think now you get it. It will be a simple DFS, maintaining the current value and returning wherever we find the leaf node and comparing. And if we have all the nodes, then we basically call call its children and return the minimum out of those. So let's go to our code editor and simply write down the solution. So let's have a inner function. Let's call it DFS, which will take a root and will take current value. Now if my root is none, then I am returning nothing. All right, here I want to update my current value. And my current value will be basically, I will be appending my root value to the front, so that the order that I get after combining an entire path is from leaf to root and not root to leaf. So it would be, now I will update my current value, and which is root dot value plus my current value that's already there. Now this has to be appended in the front of the cur value so that we get the string, final string, from leaf to root and not the other way. However, because this is a string but now it's coming as an integer, then we will have to add ORD of letter A. ORD will give us basically the number of 97. This will give us 97, and we will convert this to char, right? This is an integer that we're getting, which is in the range 0 to 25. So let's call it CHR, which is a short form for converting this whole thing to character, and there we will have our current value. And now if my root dot left and my root dot right, then I want to return minimum of my DFS on right children and right child and DFS on left child. So minimum of these value, and finally we will be returning current value. So let me just take a moment and write these two things down over here. So this is right and this is lefty. All right. Okay, and one more thing. If let's have, in case if just left child, then we just want to return left. There is no need of comparison, just return it on left. And if there is right, then return right. So we're covering all the cases here, right? We're covering all the cases here, and that's it. That's for the right. And finally we can return our cur value, which will be basically the root value, because now we have covered for every node. If a particular node had both the children, a particular node had only left or right, and then a children that did not have any, that was the leaf node. That's what we are comparing, right? And maybe, I think in this case we're never calling something that is calling a null node, so this might not be called anytime. All right, so then finally we can just return our DFS function on our root. All right, let's zoom out and test it out. That is because we are not providing the initial current value, which is empty string initially, and this is not the right. I don't know how that got deleted, but anyway, I think this should run fine, and let's submit the answer, which gets accepted. All right, let's write the time complexity. Time complexity is big of n, and space complexity is also big of n, because this time it could be height, but I would say we are storing all the leaf at a time. then it is big of h, and worst case it's big of n, when it's just one single left child of the root. So it's more like the linear array. So let's go back to AlgoYogi, mark this problem solved. We are five problems away in solving the entire tree series, which is like 49 questions done and 5 more to go. So there will be 54 total questions. All right, see you guys in the next problem. Bye bye.